Okay. Hello, everyone. Hope you had a good lunch. I have to admit a little bit that I'm a little bit nervous today because it's the first time I'm giving this lecture. Last year I gave a lecture on the same topic, but it wasn't very good. So I created this from scratch almost. I kept like a few slides. I did that yesterday, and I'm really hoping that this turns out well. We'll see. I can always improve it for next year's, but hopefully it's a lot better. And yes, teachers get nervous too. Yeah. Okay, so today I'm going to talk about designing, understanding, and visualizing software architecture. And in difference to previous years in which I just gave the students some like, oh, this is how you can visualize things, which wasn't very interesting, and most of the people knew everything already. I have decided to focus a little bit on assignment 1. Because, I mean, I think there are some people here who know exactly where to start. If you have a big structure, a big architecture, and you have like 200 classes, like where do you start looking at the execution flow? And for those of you who have a very good understanding how to do this, please help everyone else during the discussion. But for those of you who feel a little bit like, okay, how is this structured? What are all these folders? Hopefully you will learn a lot in this lecture, and hopefully everyone else will learn as well. I think that having this exchange during the discussion with ideas is helpful even for people who know a lot, because you might pick up something new from someone else. So yeah, the purpose of this lecture is partly to describe the different purposes of different types of visualizations, because there are lots of them. Describe a little bit about stakeholders. So a little bit of a recap from previous lectures, and then I'm going to go into okay, so how do I actually do this? How do we understand big code structure? How do we visualize that? I will give you some of my own ideas of how I will do it. I will look at the GitHub project, click around and see basically the first steps, because I just picked the GitHub project an hour ago. So I have had a brief look at it and basically confirmed my own ideas, like this is how I would do it and so on. So basically you get kind of my first impressions of a new project as well. Yeah, so let's get started. So just a very short recap on last lecture or previous one before Jennifer was here. By the way, did you like that lecture? Good. It's kind of cool to have someone who's worked on like Heroes 2 and 3 and 4 and The Sims and stuff. She was actually the project manager for Heroes project, which is kind of cool. And she described in the car like how she solved all the music issues, because they came up with that like just before the release, and they contacted the London Symphony Orchestra and basically got the music very, very cheap by offering them all their contacts within the game industry in Austin. So basically they just, okay, we'll play like almost for free for you guys, and then you give us all your contacts. Oh, which is cool. Like those are the things that you have to deal with as well as a manager. I think that's cool. Anyways, so lecture before that. We talked about the context of architecture, like where does it fit in within this development cycle and the different aspects with the requirements engineering, which you did on the workshop, within like designing, development, testing, and maintaining, and so on. And what we also talked about is this whole communication breakdown. When you have large architecture or large development teams primarily, you have lots of people trying to communicate, and eventually you're going to have developers stepping out outside the specification, which also means that suddenly the architecture is not true anymore. And it becomes kind of this Russian post communication, ryska posten in Swedish, where you whisper in the ear of someone, and if you have enough people, the end message is not going to be the same as the first one, because people mishear on the way. Remember this game from when you were children, maybe? I have no idea what the expression comes from, but that's the expression I know. I think there's actually other names in other countries. I think because my guess, and this is a complete guess, is that we think Russian is a very strange language. Just my personal guess. I have no idea, to be honest. Okay, so how do we overcome this? This was something we talked about, and basically we talked about documenting your changes, at least communicate it somehow. So see if yeah. So there is code route. Everyone has code route. The more people you have working on something, the more code route you're going to have. By code route, I mean the code base is no longer true to the architecture. So either you update the code to match the architecture, or you update the architecture, or you communicate it somewhat. So to simplify this, there are a number of steps you can take. Basically, if you go back to the old metrics that I taught you in the previous course, the project course, high cohesion, making sure that one class does one thing. Remember this one? And weak coupling, to make sure that there are very few dependencies. So if you change here, it doesn't affect the code over there, right? So try to avoid inheritance and all those things. So basically, make things as independently of each other as possible, because as we discussed as well, like with the whole design on a napkin, we thought that just hacking might be okay if nobody depends on you, right? But if you have lots of dependencies, architecture becomes important. So if you can reduce the dependencies, the architectural importance becomes less crucial, and making your own design decisions becomes more possible if you can keep weak coupling as much as possible. So yeah, another thing is you try to eliminate these communication bottlenecks. You try to reduce the number of like cumbersome documentation. If you can reduce the number of paperwork that just nobody wants to do or read, and communicate it verbally, or have daily stand-up meetings, etc. Those are things you can do to limit how things break down and basically improve your code. And another thing is always try to improve, like your process in the company, the process in the company you might be working in the future might have a good strategy right now, but it can always be improved. So you try to, as a developer yourself, you try to improve your code, you try to improve and try to stick to the design, and you try to be faithful to the architecture. And when you think that the architecture is crap, you notify someone and update the architecture. So basically try to improve communication. That is key and a way to reduce this code rot. So when it comes to architectural design, it's often quite idealistic. I'm going to show you some examples, and I'm going to show you a real life example from the project I told you a lot about last year because I hate it, the Demo Care project. And I'm going to show you another horrible example from that project because it's very realistic and unfortunately true. So that comes later in my presentation as well. But often there are various degrees of simplifications in architecture, basically because the architecture is often treated as something you do in the beginning. And I mentioned this at the first or second lecture, like architecture is not just a single phase. It's something that should live throughout the project, right? So if it's only done in the beginning, of course, it's going to be very, it's a course when it's not very detailed, the opposite of being detailed. So it's not going to go into detail. It's not going to go into depth. It's going to be very, okay, we need something of that. We need a module of that. And you're not going to have the proper names of things. It's going to be basically concept. And of course, that concept is not going to be true to the implementation later on because it's not detailed enough. Nobody can create code from that concept and be very realistic code anyways. Maybe a few structures in the beginning. And often these architectures that are being done in the beginning are often used to communicate with the different stakeholders. So there are different focuses, and they are foci, and you focus on different qualities. So if you're going to talk to your quality engineer or quality manager, you're going to make an architecture that focus on quality. If you're going to talk with your security officer or whatever in the company, you're going to make an architecture that focus on the security layer, right? Because it makes sense. You try to prepare material that works for your current meeting or whatever. So the pictures or the visualizations that are being generated in the beginning are often not intended for developers, yet it's never updated. And that's what I'm going to show you in the example later on. So if it's not updated to work for developers and it's still being used, of course, we're going to get these problems. So that's why I'm going to tell you some techniques and the different views or visualizations, and also what I think should be done for assignment 1 in this lecture. Okay, so some different stakeholders that might benefit from having a visualization of the architecture for somehow. Of course, the architect makes sense. We have some form of designer, even if it's for other system. They might look at resource consumption, performance issues, and stuff like that. We have an implementer, which might look at constraints and so on. We have a tester, integrator. Might look at the black box and white box testing, the different behaviors and so on, based on the architecture and the requirements. So you match the requirements towards the architecture. Of course, you have a maintainer, which makes sure that the architecture is updated and kept up to date along the project. And I'm going to cheat a little bit because I have notes in my slides, but they are not scrolling down. Okay. You have the manager. So the manager has to look at the development team. They have to look at what kind of staff they have available, who's going to work on what part of the architecture, how do they divide the work, etc. So that is an important aspect. Quality assurance people, of course, that is, does it conform to the architecture we set? Does it solve the different features we have set, and does it do that reliably? So these are different stakeholders, and of course, each of these have different interests, and there are different diagrams to serve these different people. Just some terminology. So there are system stakeholders. So basically, they are whatever team or whatever individuals that are interested in the system. So stakeholders. A view, basically looking at a specific part of your architecture, so that relates to a specific purpose or target or concern. Like, okay, so this is the security view. This might be the like communications view or whatever. And a viewpoint is like, okay, so you make a visualization for a specific audience targeted to specific stakeholders. So because I might use these terminologies, so I might have a definition of them. Okay, so for a viewpoint specification, yeah, so what the things you need to define and look at is like, okay, of course, what's the name of it, just to have some way of communicating. Other things that are very important, you need to decide when you visualize something, who is this for? For assignment 1, can you tell me who the assignment 1 is for, based on what I've told you already about like the purpose of the assignment? Anyone have an idea? You? Good answer. And who are you? What kind of stakeholder are you? I would call you a developer, right? Or implementer, or someone, or even architect maybe, because you are going to do these assignments along the way. So you need to understand the code, but since you're not going to do a lot of implementation, you're going to do a little bit of it. So you might have it's kind of a mix for you guys maybe. So a little bit of structure, a little bit of going into depth into something, right? So the purpose and the stakeholder is half architect, half implementer, and therefore you should be able to describe the architecture from an implementation point of view. And that's also the way I'm going to correct it. Like, did you understand the code and the structure and the architecture? And did you manage to communicate that? Because communication, as we said, is very important. Some of you look a little bit skeptic or hesitant or whatever. Is it there's something unclear? Feel free to just complain or raise your hand or ask questions. Okay. Yeah, so what does this visualization concern? Of course, for assignment 1, that also means that if you have a huge structure, I don't expect you to do very detailed about everything, because you're going to end up with tons and tons of diagrams. And yes, I would like to have an overview where you look at the modules and so on, but the details, when the fine-grained details, it's okay to keep that towards the module in which you're going to work in for assignment 4, right? Because that is, what you are as an implementer. You're going to implement something for assignment 4, so that's where you go into detail. Yeah, and of course, what language do you use? If you talk to business people, if you talk, you use business language. If I talk to healthcare people, I use healthcare language. If I talk to implementers, I use their language. So, and also the modeling techniques. Of course, we have different symbols for different people. Business people use the same symbols as software engineering people, but they mean different things. So I'm going to go through some symbols later on in this lecture as well that are typical, that you can use, that are somewhat well known. Some you're going to recognize and some are going to be maybe new. But it's good to learn these because it's quite likely that other developers that you try to communicate with have learned these as well. So you can save yourself a lot of explanation by just using the right symbols. We get to that later on. Okay, so this is Christian's 4+1 view model. So basically this is a multi-approach way of describing architecture that is quite typical for projects. And the different views that are, often you generate several views of your architecture in the beginning of a project. So you have your logical view, and that's what you did in the last course. In the project course, you did like all these use case diagrams, and you did storyboards and stuff like that, right? So that describes the functional requirements, basically. What functions, what logics should the software handle? And who are those for? What are the stakeholders interested in that? Anyone? Okay, so that would be either users or the system experts, typically, right? Even in some case, the business people, the marketing people, where you try to explain this is what the features our software going to have in the future, but you often it is to get early feedback on like, so did we understand the features you wanted, like the customer basically in this case. So this is kind of what you did on the workshop, right? You did requirements engineering, which you generated a lot of logical views, mostly was user interface and stuff, but that is kind of like a storyboard. So yeah, and you probably listed a number of features in text that you might not, well, you might have just written them down and not explained it to a customer later on, but probably you just talked, right? And through your talks, you came up with a lot of features and so on. We have the process view, viewpoint. Process viewpoint is typically activity diagrams, sequence diagrams, and so on. Basically, it describes how your view looks in runtime. And the people, you look at like performance, scalability, and all those things. People who might be interested in such an architectural view are, of course, developers and so on. But also quality engineers, because they want to make sure that this will actually work for millions of users. Anyone here play Pokemon Go? They designed the software to work for 100,000 users, and then they got 5 million. So they had some problems in the beginning with servers not working properly and stuff like that, and they had to reduce or remove some features in order to get everything to work properly. And they also forgot to pay their licenses for stuff. We have the deployment viewpoint. That is also called the physical viewpoint. If you look at the diagram on Wikipedia, it's called physical viewpoint. But basically that describes, okay, so you're gonna have a client, you're gonna have a server, so this goes there and that goes there. You might have some like this processor and that processor. You might have multi-threaded applications that goes on different CPUs and stuff like that, or different threads. So you allocate things onto different entities. So of course that describes communication again. This relates to implementers, but might also relate to people who try to get the overall architecture, try to understand how things communicate, the dependencies and so on. So of course the architecture is very interested in this part, just make sure everything works. And then we have the implementation viewpoint. Basically that will be all your class diagrams and stuff like that, module diagrams, package diagrams and stuff. just to describe the qualities of the implementation. So now I can probably skip a lot of these because I said it. I prefer doing that. Implementation. Yeah, so you have the component diagrams. I'm going to show you one of those later on because I don't think we went through that during the previous course. This one has low battery. Did I miss a slide here? The deployment, implementation, and then we have the middle one, the +1, which is basically a scenario. So the scenario plays a role in trying to describe how everything fits together. Like, how does the implementation relate to deployment, and how does that relate to the different use cases and functions and logical view and stuff like that. So this is perfect for talking to the owners or the customers or the managers, just giving a good overview. You can have these use cases described as a long scenario, for instance, where you try to map things, you go into a little bit more detail, so stories. Then, of course, we have other views. We have module views, component connector views, allocation view. I'm just going to show you a little bit of this. Module views. Anyone here does not know what a module diagram is? You've seen those, right? I'm going to show you a few. So I'm not going to go through this too much, just to skip it. Component connector views. I did have I have next picture is what I was going to show you. So basically, these describe the different processes, how they fit together, how they connect to each other. You also show the concurrency, and you can look at parallelism and stuff like that. What data storages there are, what shared data, you have client-server connections. I'm going to show you what it looks like. So this is a component connector diagram. So this is the connector. And you can see here we have a sensor driver. It describes something about how it connects to it. You have observers. Here we have an alerter. We have a Sparkle endpoint. So that's the storage. I'm going to return to this picture because that's from the demo care project. And I'm going to tell you why this is horrible later on. But this is what it looks like anyway. So you can have these different components. So a knowledge management component. So this does not describe the module, and as you can see, knowledge management, that is a horrible module name, or it's not like a single class. You have here's a web service and so on. And allocation view, basically how you allocate it to different, host machine, PC machine, who's doing what. Okay. How do you decide what to show and what to view? Of course, you need to look at what stakeholders are interested and so on, and select the viewpoints from there. And you have these different 4.1 or 4+1 descriptor, but prioritize and try to combine the different viewpoints if necessary. So that was kind of like the basic, these are the different views. Now let's go into like some examples of what is quite typical. Have you ever seen something like this? I showed some of you yesterday, but so this is quite typical architectural view made in the very beginning of a project. So that's why I'm saying maybe it's not so good for development. But typically, they generate a picture like this, and they put it on the wall because it looks nice and has colors. And if you talk to a non-implementer or non-developer, they're going to go, oh, that looks nice. It's also divided. And, oh, here we have like inspection workstations. And it's so neat and only has these many things. And it looks very nice, right? And you have the different, like you have a license item database, you have security ID systems. You can see that there are at least some thought put into like, okay, what do we need? can you create software from this? Like to make it true to the architecture? I see a lot of people shaking their head. I know a lot of people that try to make software from this. I've certainly tried in the way past, and it ends up being a whole mess, because what actually goes into this, and how is there any communication between here and there? Which sometimes there is, and I'm going to show you that in the next slide, because this is another picture which is very typical, and this is a picture that was in the technical specification of the demo care project. And for those of you who were not here in the last course, demo care is project, or it just ended last year, was a project that did support solutions for people with dementia, basically a remote diagnosis of dementia. So we had lots of cameras and lots of sensors. That was going to be like, you analyze the data, you come up with some behavioral views and stuff like that. You try to have an interface that tell people you are wandering around, you're pacing, go to bed, go back to bed, and stuff like that, or alerts. Like, oh. So this was the architecture for quite a complex project. I wouldn't say that code-wise it was super big, because I mean we probably only had a few 100,000 lines of code, which isn't that big. But we had lots of development teams with lots of different cultures. And people try to like make sense of this. Okay, so we have some form of enterprise service bus here. So all the basically in the beginning when we talked, the technical partners talked, and we basically decided, okay, so there's going to be like a one tunnel, like there's going to be a nice API with all the communication in it, right? Like get and set maybe, or maybe you can even have an observer, yeah, something simple, right? And yeah, felt good. And I mean, for whom is this architecture? Well, it certainly wasn't for developers. We already established it's very difficult to create an architecture or implement something from that. So, I mean, can it work? Can you keep this updated? Well, there's no point, because it's not going to be true to the implementation. It's nice to discuss or to communicate this in a research article. It's nice to communicate it to the stakeholders, like, okay, so we have an idea of what goes in here, just to have a nice picture in a report. But for implementation, no. And I'll tell you what happened then as soon as this works. Okay, so this is the component connector diagram for that exact same thing, right? So this is, okay, so it's not a class diagram, but it should describe how things fit together a little bit. The processes, the communication, right? Do you remember like there was a nice middle layer which tunneled all the traffic? I don't exactly know, like this is storage, right? And if I remember correctly, that's down here. This is the knowledge base, this is storage. That's the Sparkle database. This here, and then we have all these other things. I mean, these are a number of different things that weren't even in the previous diagram. And we have lots of observers, and then we have an alerter. Alerter, I feel, is kind of an important component, right? I mean, it's the whole pushing thing. And an alert manager, I mean, that's a very central component, because it's the whole interaction part for only two of the interfaces. So where is that? And then we have security. Of course, we're going to have security through the entire project, because it's important that stakeholders know that we are very secure. I can tell you that even in the very end, the only part that had some form of security, and I'm not claiming it was very good security, but it was some form of security. It was the patient interface, because I did that one. And everything else was zero security. Because when I designed mine, I thought it would be nice if we could like run the interface on the home computer while all the data is on the server somewhere else. advanced, right? While everyone else thought, let's just implement, or let's just deploy everything on every computer in every home. So we need a server at their own home. And then we don't need the security because there's going to be no internet connection. Yeah, so that's what they did. I did not agree with this because that was completely unfeasible, especially since it took 2 days to set up the computer because they needed a specific Linux distribution and stuffs. So, because that was also not clear from this, because there's no allocation diagram here, right? That was missing from the technical specification, no allocation diagram. If they had said, this is going to run on the same computer, the client interface, the UI, the server, all this backend, all the analyzation, the processing is going to happen on the same computer, I would have gone, that's not a good idea, let's redo it. But I assumed it was going to be distributed because to me that made sense. I mean, it makes sense to have all the complex processing on, at least if you have a nursing home, you do one server in the nursing home and they have like 5 or 6 clients communicating to that, right? That makes sense. And it's still fairly secure. If that host in the nursing home has no connection to the outside, you have to be inside to like do anything, right? That's fairly secure. I would have expected that because that's a very typical scenario and you would have saved lots of money. Instead, you have to have quite a powerful computer that is very noisy in every person's home. Or every person's, even in the nursing home, they have these rooms, which is kind of like an apartment, in every apartment like that. And they don't even like computers, most of them. So that made no sense. But there was no allocation diagram, so I assumed. And there's some saying about assuming, making an ass of you and me and stuff like that. Okay, so these diagrams are important. The different views are important. By having the allocation diagram missing, by not having this match the previous one and thinking this is enough. Because this is like, architecture's done, go implement things. Basically, that's what they said. And actually, these diagrams were made by the same people, the French military developer for military air defense, I think. So they are like professional developers that do like quality stuff, supposedly. But they do not know how to make it an architecture or communicate it. At least not these people who were involved in this project. There's also, of course, I'm not going to blame all of them because there's also like whole communication overhead and it's not so easy working on EU projects because it's messy. Okay, so why don't we do proper architectures and model it properly? Well, if you try to do it all at once to make it one picture, it becomes kind of messy. And if you use one of those automatic re-engineering tools, like, I don't know, Modisco and stuff like that, some projects are going to end up looking like that. And I know that some groups last year tried to clean that up. And I think some of them kind of managed, but it took a lot of time. So, I mean, how do you actually look at a piece of code or a big structure and try to find an understanding? So that is what we're going to talk about after the break. So 5 minutes. Can you still hear me in Skellefteå? Because I had to change microphone. Battery was out. Just not. I cannot hear you though. See if they. I could see you talk, but I couldn't hear you. I still can't hear you. You can send me an email if you have something to say. I'll go check it. Can you see my slides now? Good. That's my mistake. I forgotten to share. I can show you the slides that we have so far. I go from the beginning. Okay. That's a code.slide. Not when you run reading. That's not so important. Here are different stakeholders. So that's the view I showed that I talked about. That's the component connected diagram, which is terrible because it's wrong. I get back to this allocation view, where you allocate different entities. Okay, so that's a typical architectural view. And this is typically not for developers, but it's very typical image you see in the beginning of the project. You don't need to read it all, it's just to get an overview of what it is. And that is from the architectural view from the project, the Demet Care project. You can see that there's like a nice distribution enterprise service bus in the beginning, but it doesn't explain like any, it doesn't say that he should have contact with the knowledge base or anything like that. So this is the same view, but as a connector diagram. You can see that there's, from the GUI, there's a connection directly to the database, the Sparkle query. There's an alert manager, which was not in the previous one, and still it's very granular, so it doesn't really explain how to implement anything, right? And this is how it can look if you just generate something. It's very annoying. And that's where we are now. So a brief recap for the video. Okay, shall we continue? I have now caught Skellefteå back up because they didn't see my slides. So, okay. So back to why we are discussing architecture and the problems that architecture solves. And how do we actually maintain something complex when code itself is such a living thing? And how do we visualize and communicate it for developers? Well, I'll start with a statement. So software architecture is about dependency management. I mentioned earlier that the reason why architecture is important is when other people depend on your code. If there are no dependencies, then basically your stuff is a separate application. And as long as that one runs, it doesn't affect anyone else, right? Except for if someone else is going to read your code later. But that's when you have like design on a napkin or just hacking, is when there are no dependencies. Then that's okay, when there are very modularized code. But architecture, you try to manage all these dependencies between different components, between modules and so on. And I'm going to read you a quote. Architecture exists to define dependency flow and to create strategic pockets of isolation, both to minimize the impact of necessary changes and to help with organization and divisional labor. So what it says basically is dependencies again, the flow of things. Isolate, if you can isolate things, how you modularize things, how you separate things, how you keep things cohesive, and how you maintain weak coupling, right? And it's also about this whole divisional labor thing. If you have lots of developers, who's doing what? Who's responsible for what? When something breaks, who do you contact? Which team do you contact for that? Or who's responsible for making that module? So that is the primary reasons why we have architecture. Of course, there are other reasons, like if you have architecture, you can actually put some thought into optimizing, reuse, and designing for specific quality attributes. And I'm going to have, I think it's 4 lectures on quality attributes, where we discuss like usability, maintainability, scalability, performance, all those different quality attributes, right? Or some of them anyways. So we're going to look at those and how you would actually go about designing a system specifically for that task. Like what kind of tactics can you use? What kind of techniques are available to you, and what do you need to think about when it comes to your code? And we have a lot of discussions about that as well. Okay. How do you actually maintain code then? It's something that's starting to pop up. I don't know if it's been around for a long time, but I've seen it in several places already. It's this whole information radar. And it can come in many different shapes and forms. I've seen this one primarily, where you have red, yellow, green lights. Typically, I see it for code when it comes to working, or there are some bugs or broken code. Basically, it's the state of the code base in those cases. However, you can also use it for, is our code still true to the architecture? Or do we, because the moment as a team, if you have this view, and it's easy to just get a glance. And in bigger teams, you might have a quality assurance and a manager, and there are people working specifically where their only job is to basically to maintain good quality code that is true to the architecture. And the guy who wrote this quote here, he's one such guy who basically his job is to maintain good quality code and update code or comment on, okay, so this could be done differently and so on. I think this visualization, just to get a good view of what's the state, just to give everyone the responsibility and remind everyone, okay, so we made some changes, so we need to keep updating things, and our aim is to become green again, right? And it becomes like this push. And if you do this continuously, it's not as difficult as if reverse engineering everything from nothing, which is what you're doing for assignment 1, which is basically, we have no architecture, let's see how it works, and trying to get a good understanding. So that's what you're doing. But if you have a living architecture, it doesn't become like a 2-week job to figure everything out, right? Another way of doing this information radar is to have like just post-its here, pink, orange, or yellow, or pink, green, and yellow notes, just to signify the same things, red, yellow, and green. And here you can actually put features. You can divide it into different slices in different areas. So this might be the security module, and here might be the UI, and you can specify what parts are no longer true. And you can, as a developer, if you know that you made some changes, oh, I'll put up a yellow note here. I'm working on it. It's in progress. I'm going to either update the architecture or fix my code. Or green, it's true to the architecture. It's tested. It's implemented, and it's in the baseline now. Or pink, I've done some things. I am not currently working on it. Something like that. Of course, every company is going to have their own way of handling things. I'm just giving you some tools that are available that you can use for this purpose. Of course, you can like write small notes and text and stuff like that as well. But I think a system like this is not so difficult. Just to write current module, status, being worked on. Like you can do that during the stand-up meeting or before or just after. Just keep people to communicate with people. Okay. We're going to have a short discussion. I don't know exactly how long, but I'm thinking maybe 10 or 15 minutes, where I would like you to discuss basically, so how do you analyze design? Have you all had time to at least have a first look at the code base for the projects you've looked at? Yeah. So you know that there are a number of different modules, classes, and folders. A lot of folders that have no code in them. There are for other things, like in the libraries and stuff. So how do you find out where the good stuff is? Like how does your project, the structure actually work? How do you understand the dependencies? Like where do you start? How do you address this? How does your program run? What's the execution flow and stuff? What features does your program have or your system? And if you had a feature, where should you add your code? And also then, how would you go about visualizing this? Like basically, what do you think you should deliver for assignment 1? And at what level can you create a visualization that is possible to maintain even if things change? So I would like you to just have a discussion, like 3 or 4 people. I know that sitting in benches like this is not optimal. Feel free to stand up or whatever. And I can actually recommend that you grab some people that are not in your lab group, because that means you might get more knowledge from other groups. Otherwise, you keep it internal, so to speak. But it's up to you. I have pens and papers up here if you need to write or draw anything. So do you want me to distribute stuff? I can just send some things through. Is everything clear? Yes. And we'll stop the discussion when I think nobody's discussing anymore, or when we reach the time limit. Good? And in Skellefteå, I guess you can just think for yourself, I guess, and you get the results later on. Okay, the discussion seems to have slowed down a bit. You have enough to at least contribute to discussion, right? So, can I get some input? Any group want to report a little bit? Nothing to be ashamed of, please, please. Find the documentation, yes, very good. That's a very good start. Not all projects have them, but most larger ones have some form of documentation. And it's not always on the GitHub page, for instance. It could be a separate web page. Anything else? Find a wiki if they have one, absolutely. That's also documentation, yes?
One idea is to search for separate examples of tutorials, because most of the time they add important modules and classes, and then you can create a model.
So find tutorials, find examples, FAQs could be one thing. Together with the documentation, there are sometimes like frequent asked questions lists and how to get it running and how to get it started, or there might even be a good explanation of that. Well, that's part of the documentation of the different modules and stuff. But there are sometimes discussion forums where there might be information you can find. Anything else? Absolutely. If you need to fix a bug, you can use a debugger, you can use breakpoints, you can do trace sprints and all those things. There's going to be a lecture towards the end where we talk a little bit about debugging as well. Anything else? Okay, I'm a little bit surprised that nobody said find the execution flow. Let's do that. Okay, let's see if I can. Okay, so this is CGO. This is a program for geocaching for Android, and I don't think anyone took it because there was a big warning sign on it on the web page. The reason because it's a very difficult setup. Apparently, all the groups I've had who've taken this project in the past have failed, or they succeeded eventually, but they spent like 30 hours to get it to run even. Okay, so if you look at CGO like this only, there's quite a lot of folders in the root. So, okay, we can start first with find the documentation. Well, first of all, there's a web page up here you can go to, or you can also go to the README, which will then bring you to, the different information. Here you can see how to set it up, how you can build it, APIs. Here, basically basic documentation how you get it to run. But of course, there's a web page listed here as well. Open that in a new tab. And here you can see the development tag, you can see source code, developer chat, website, beta testing, nightly builds, stuffs. I believe there's a discussion thread here somewhere as well. Unfortunately, to my knowledge, or just a brief view I've had on it, there's like not a good architectural overview, but there is at least some commenting and stuff. There's APIs and stuff. Change law you can see. And I think in the support there's a discussion forum. Bug tracking system. You can see getting started, but mostly this is for use and not so much for development, unfortunately. Okay, let's go back to the project. So that is, you start looking at the web page. That could be a good start. Okay, going back to the folders. If I would start and try to find, okay, how is this structure, where does it work? I will start trying to find the source code, and that's not always so easy. In my case, I mean, there are like .github, that's just some settings, I guess. CGO calendar, CGO contacts, Crodin, wrapper, leak canary, main maybe. That seems logical. And here's another lot of folders: settings, compile libs. So those will be, for those who are not very good, very experienced programmers, libs, libraries. If you look at those, there will be compiled libraries, typically jar files or bins, bins would be in the binary folders typically. So the bin files, bin folders, I mean. Project, I'm guessing that's project setup files or something. Style fixer, that's comments on the Eclipse installation stuff. Source, SRC, I think that's a good place to start, right? I'm guessing that's the source code. And then we go to the CGO folder. So here we find 3 modules, then probably calendar, contacts, geocaching. Well, since it's a geocaching application, go to the geocaching folder. And more folders, but at least we have source code. Yay. Okay, what would I call it? Where would I find my main method? Well, unfortunately, since this is Android, you won't find the main method anywhere because they basically extend the application class in Android. But where would I find like the start? Where does this program start? Well, if I look at the names, I would probably go to CGO application, right? That sounds reasonable. Sounds like the application start page. So if you go look for that, you can see that it extends the application class, which is Android default, which basically has this setup methods and stuff like that. And basically you override this on create. So this is basically how it starts, I guess. I'm not an expert Android programmer, but I'm assuming that. So from here, you can start looking at execution flow, like what happens on create, and you can start like, okay, install some things, and obviously you need to understand how Android programming works to get all of the flow, because some of the flow is like default. This is how Android's application works. But you can start looking at the different methods. So you can start like, okay, so this this extends application. You can look at that one if you want, and so on. And you can start like, okay, what happens when I run the application? You can start stepping. You can do here again. You can do breakpoints. If you have this in your IDE, your development tool, you can say, okay, step-by-step instructions. What happens? Which classes do I go into? And you can find, okay, when I run the application, it starts this one here. It gets the information from that method in that class over there. And then from there, it goes here. And you can start in your mind to just picture, if I press this button, it goes to that class over there, which is located in that folder. So you can basically create an understanding from executing the program. Does that make sense? Good. Okay, so that is the execution flow, like finding that, which is, it takes a bit of time because it's some, you have to work on it a bit and you might have to do some breakpoints and trace prints and stuff. But what are all the other folders here? Okay, I don't know, for instance, well, I mean, settings, I know what that is. I know what the sensors folder is because by the name I can kind of tell what it is. So let's see something that I don't know. Connector. What is the connector folder? What does it do? I don't know. Let's find out. I still don't know. Okay, abstract connector. That's something abstract. Probably that's, I'll see what it is. It's a connector. I'm hoping that says something. And there are no comments. What to do? It still doesn't tell me much, right? Except it does tell me that it implements the eye connector, which is the interface. Maybe they added the comments in the interface. That's the eye connector, right? It's an interface. And we have comments. So by following like what inherits what implements what extends what, I can start like, okay, where do they have the documentation? This also tells me something about the style of coding. They use interfaces and they put most of the documentation in the interfaces. So if you're going to make changes in your code or add something, they probably want you to have an interface, put most of the documentation in the interface, and then you can code the rest, kind of. So it tells me something about how they have decided on code style and stuff. So if I look at can handle geocode, so basically my understanding on looking at just a long browser URL for given code, watch list. So I'm guessing this is basically kind of an arbitrator which connects different parts together and checks whether certain things can be handled and stuff. It might be something, an explanation or description I might need to refine along the way when I get more understanding. But maybe at least this point, I get a brief understanding of what this connector module is. And maybe that's enough for now. Okay. I'm doing this for the kind of I did it like just before. So, okay, so that is how you can take something that looks fairly extensive, right? I mean, this is not the largest project by far, but it's fairly complicated still. It's not something you get a grasp on in 20 minutes. You need a little bit more than that probably. But at least you can start finding how does it all fit together. You look at each of these folders and see what are the relevant ones. If you look at the execution flow, you can see by just running the default application, by clicking these buttons, I access these different modules, these different packages, these different classes, and so on. Have you done something like this before? I assume some of you have, but you didn't add it to your discussion. Some people nodding. I find it quite helpful to just do that. Of course, documentation is great, but it's not always you have that. And you should start with that, of course, because if there is documentation, that's by far the easiest way to get started. Yeah, let's go back to any questions, by the way. For those of you who are not very experienced, that's a bad question because stigmatizing. If you have questions about how to get started, you are absolutely free to ask me questions via email or whatever, and I'll be happy to help. I had some people last year that studied business economics, and they were not programmers, but they still managed to do this quite well. So by looking at the structure and finding where's the source code and going from there, basically. So it is kind of an investigation job, and yeah. And knowing like bin is binaries and lib is libraries, and some basic acronyms. Okay. So how do we visualize this then? That was one of the questions for you as well. Anyone have any feedback on that one? Like, how do you visualize that? What should you deliver in assignment 1? UML? What kind of UML? There are lots of UML.
Well, let's get the bullets to narrow down on what would be relevant to what we're going to pick in assignment 4, maybe, and try to abstract away some details that's not relevant.
Abstract away details, very good. And just to extend on what your answer, because you said something overall and then go into depth, I would probably start with a module diagram, and each module I will probably write a sentence or two just describing what it is. Basically what I did now on the connections module. I looked at it, what does it do? I got a brief understanding. That explanation I gave now, maybe I would have to refine it a little bit because it was very vague. But I could start like that, and I could just write a little bit on each, create a module diagram, how do these modules fit together, and then my module, I might do a class diagram on that one. And if we look at some of these modules there, I mean, a class diagrams with 20 classes, you can visualize that on a page. And since it's a digital upload, you can put it on an A3 page. You can put a huge picture. I can zoom in on it, whatever. So it's okay. It doesn't need to fit on like a small paper. But if it's 100 classes, maybe you need to focus on a specific part. Or you can just say, these classes on that side, they do things that are not relevant to mine, and you just try to summarize, make your own kind of abstraction of it. So abstract things, very good. And that also tells me, as the person reviewing your assignment, if you're able to make good abstractions, that tells me whether you understood your code or not. Being able to create good abstractions, good classifications, and I know we talked about that during the last course, classifying code and stuff like that, right? Being able to do these abstractions, classifications is very, very important, and understanding how you can group things together, because that makes things a lot easier to visualize. And then if you were to divide the code later on, so I'm going to reverse engineer architecture, I'm going to give it to people, and they're going to continue developing from that. Then of course you can expand on so this team is doing security. Okay, let's expand on that. We're doing that abstraction. Let's expand on that abstraction. So eventually you're going to have like a big diagram, but it's all split into parts, right? Good. Okay, so I already covered this. So there are two things that I do when I try to understand code. Top down, which is what we just talked about now. Look at the file structure, look at the different modules. Okay, so these modules here, they probably do that thing, and I go down into classes, and then eventually code and try to find how do these codes things together, what inherits what, and so on. I create some form of mental understanding of how things work. And then the other one, I showed you that as well, very briefly. Follow the execution path. You can use breakpoints, you can do trace prints, just to see what's being accessed when you run the program. So those are two ways that I use myself, apart from documentation and stuff. Does that make sense? Did it add some new knowledge to some of you, or? Oh, good. I taught something. Okay. Not sure if this slide is super interesting. Raw view abstraction. We have source code, execution, trace, and build scripts. I already said that. Database construction. Yeah, there are tools for that. That will help you visualize databases and stuff. Let's skip that. Okay, I have 10 minutes, which is perfect. I think that'll be absolutely sufficient. Some visualization. Let's skip this because we already covered it. There are actually, okay, I'll go through it quickly. There are some terminology that you might hear about visualization, about the different tools and so on. Of course, we need to decide who it's for and what to visualize. There's something called the picture, interaction. Interaction is what people do with their model, what they do they actually do with it, and stakeholder interest and so on. There are some metrics. and that's what I want to get into. How do you evaluate whether your visualization is any good? Okay, so first metric, fidelity, and basically is how well does it reflect the system that you actually build or that is built. Consistency. So if you have, probably the best way for me to explain this is a metaphor. So the Windows desktop is a metaphor of our old desktops, like table with files and folders, right? So consistency, if you have an existing software and you have already existing concepts, you can start looking at consistency. How well does your new model fit into the other concepts that you use, similar concepts that you used, or even similar other types of programs? How well can you explain your model based on what's already there, what people know? If I'm trying to explain a new software, I would probably say it's kind of like Google whatever, because Google has the software for everything that you want to make, kind of. So it's kind of like that, but so that is usually how I start when I start a new idea. I would like to do a gamification thing. It's kind of like Pokemon Go, but we do this instead. People, oh, okay, so you get a similar concept thing, right? You can do the same with architecture. Comprehensibility. How easy is it to understand, basically? If you give me a diagram with thousands of connections between each other, it's not very easy to understand. The comprehensibility is very low, right? Dynamism, or however it's pronounced, basically, how easy can your model change over time? Of course, that has to do what medium you're printed it on or what medium is in. If it's a digital model, it's much easier to change than if it's on the paper and only on paper. But also how well it is structured and so on. If it's very modularized, it's much easier to change over time. View coordination. Well, if it kind of is kind of similar to this consistency. Basically, how well it's consistent with other visualizations, how well it's kept up to date, so to speak, with those. Aesthetics. How good looking is it? How good looking is it? Simple as that. And extensibility. Can you add new capabilities? Which is also very similar to dynamism or dynamism. Yeah. You borrow things from other visualizations and make sure that you're consistent. You don't use one symbol here and then use the same symbol for something completely different somewhere else, because that's going to cause confusion. That makes sense, right? It's just simple practice. Just don't mix things up. And that also means you need to know what symbols mean, because otherwise you're going to misinterpret things. So you're going to use it, someone else that is a database symbol. Oh yeah, but I meant web page, And I see that happen a lot, and it causes confusion, because if you assume that, oh, but that's a database, and it isn't, you don't ask questions because, of course, it's a database, it's a symbol. And then suddenly you implement a database and they go, yeah, but I wanted a web page. Well, that's not what you wrote. I did here, web page. So yeah, know the symbols, and I'm going to show you some symbols in a moment. Give meaning to each visual aspect of elements. So you're going to see in the symbols soon that they try to model the symbols to mean something. So if you create your own symbols, and I promote that, I mean, you can absolutely just scribble things on a whiteboard and then things take their own shape and form. So if you want to make a flower of something, then make it mean something that has to do with flowers. So try to figure out symbols. If you need a smart home, draw a house, whatever. Try to make symbols that mean something. Okay, I'm going to skip that one. And here we have some common symbols. These are typical from UML, use case diagrams and stuff. You probably recognize these. So you have actor, you have use case, you have a boundary, which is typically like a scenario or a set of use cases set together. relationships, and so on. For activity diagrams, you have a start, you have state diagrams, you have a message, you have a signal, task, and so on. Decision, in these activity diagrams, you have these symbols, right? So these are basic UML things. I will not go through those in details. These are for other types of development. So you have a process, a tagged process. You have a tagged document. So this is supposed to look like a document somehow. Again, a decision, input, output, manual operation, terminator, manual file, display, delay, on-page reference, off-page reference, and so on. Multiple documents, which is very similar to that one, except it's many. Database, disk storage, number of lines. The database holds many different storages, and the storage holds one storage. And floppy disk is floppy disk. They don't use those very often anymore, I guess. Yeah, so these are some of the symbols. I think I have another as well. Oops. Yes. And then we have, for class diagrams, you have a number of different these as well. You have a component with 2 inputs, for instance. You have different lines for aggregation. You have composition. So these are also UML stuff and so on. Again, the database. So, and of course, if you Google for software engineering symbols or software implementation or software development symbols, you're going to find a ton of standardized or commonly used symbols. And I recommend that you at least have a brief look at those when you start learning about visualizing things, because they are quite helpful for people who know them. If there is some obscure one, then it's no point, because the whole point is that the other person you're talking to also know. Otherwise, you might as well just make up your own stuff and define, okay, this is what it means, and then use it for the rest of the development time. And in whatever company you're going to work in, they probably have their own symbols, which is fine. Just make sure you learn them, because it saves you time. I have 2 minutes or 3 minutes. Okay. So if you make new symbols, make sure you're consistent. Here we have the same symbol. They're all squares, but they mean different things. So here's a data connection, which might be, a control connection, monitoring connection. So these are 3 different things. And here we have at least these had okay, so these lines are different things, but they are the same lines, right? At least these were consistent, they're all clients. Here we have all 3 clients, but they have different symbols. What's the difference? It's not communicated. They're clients. Why don't they have the same symbol? But here we have the lines are different, so maybe these lines should have been, might be those lines there, right? So you use lines for different things, you use symbols for different things. But don't try to have 3 clients with different symbols when they're not supposed to be different symbols, because it's very, very confusing when you talk to people. Here we have decorations. These decorations mean 1-to-1, but if you don't explain this, usually you put a legacy somewhere, like this is what the symbols mean. If you don't have that, what does it mean? Is it 1 client or 1 connection? I don't know. Here we have the wrong symbols. So here someone has used the database symbol for business logic and the data store for a document, or a document for a data store. So that's completely wrong, right? Based on what they looked at before. So I think this is kind of my final slide before the summary. If I would like to construct new visualizations, I need to basically describe what it is, what it means. Can I achieve my goals? Can I actually model things based on my new visualization if you just make something up? Do I reuse other similar things? Do I base it on common knowledge? And so basically, does it coordinate with other things? Do I augment existing things or just improve on something? Like the document, the multi-document was a document, but several. That's augmenting one current symbol. Yeah, so basically try to, when you create new things, just try to think a bit further than just scribbling. Spend 10 seconds on like, thinking it through. To sum up, yeah, so to keep your architecture updated, communicate things, reduce the communication bottlenecks, and make the right visualization for the right target audience, the right stakeholder. And if you're gonna try to reverse engineer something, there are lots of tools to do this with. Any questions? I have a very short question for you. Did you find this lecture valuable? Should I improve something for next time? If you have any feedback, please write it down so you remember it for your course evaluation later on, because I did recreate this because it was terrible last time. So yeah, good. Thank you very much.